Hi guys, this is Maurizio. This video will allow you to start using the PSE-3000 and OpenPNP. Other videos will be available soon. Thanks for buying the PSE-3000 and don't hesitate to contact me if you need help.
OpenPNP is an open-source system for SMT pick-and-place machines. Thanks to the OpenPNP system, nowadays are appearing on the market different desktop machines. Once you understand the system, it will be easy to prototype a project or to integrate your machine in a small production line. The advantage of the PSE-3000 is that you don't need to tweak or assemble anything. The machine arrives calibrated and fully assembled. You can start to use the PSE-3000 since the first day. The system has a firmware, a hardware, and the software. Firmware and hardware are already set up. Now, we need to take care of the software. But first, let's unbox the machine. The box is big because the PSE-3000 travels inside a foam mold for maximum protection. When you lift up the machine, don't grab from here. This is the communication rail for the feeders. And here it is on the desk. We need to mount the pump and the nozzles holder. Let's go to the PC to install the software. And if you are using Windows 7, the drivers. This is the folder you will receive. It contains the configuration files for the PSE-3000 and other programs. The configuration folder should have your name on it. Let's go to the OpenPNP website to download the software. I need to spend a few words about which release to install. We will for sure install the version 2. The new releases contains new features, but may contain bugs. So we go to the archive. A few weeks ago came out a new release of version 2. As you see, the previous release was of March 2023, then for 1 year no new releases. It was a quite stable release. So it is up to you what you want to install. Said that, I've installed the new release that I'm testing. So far it appears to work fine. So I go back and I download the last release. Windows 10 may give you this message. It is all okay. So we click on the 3 dots and then on Keep. Another warning window will appear. Click on Show More. And then on Keep Anyway. It is the moment to install OpenPNP. We keep the default directory. We select Never for automatic update. Now, we need to copy the configuration files in a directory that does not yet exist. The directory name is .openpnp2. Yes, there is a dot in front of the name. It will be created after the first start of OpenPNP. You'll find the directory in this location. Pay attention. You need to close the program before you copy the files, because OpenPNP saves the actual configuration every time the program is closed. So we launch OpenPNP, and then we close it. Then we open our target directory. We delete all the files in it, or we move in another path, and we paste our files and folders. Before launching the program, we need to do something. If you are in Windows 7, you need to install these two drivers: STM32 serial port driver and CH341SER. It is the moment to connect the machine to the PC. First, we connect the power line. The USB port on the left is for the top vision camera. The USB port on the right is for the bottom vision camera and two serial ports. But the machine may also come with only one USB port depending on the future developments. Then we turn on the machine. Now we connect the two USB cables to the PC. If you use a USB hub, do not connect both cables to it, but only one. If you later on cannot start a camera, maybe you could try disconnecting and reconnecting the USB cables, or you could try to change the port. But usually it will work without problems. Next step is to take note of the serial ports in Windows Device Manager, because we need to set them in OpenPNP. The two serial ports we are looking for are RepRap firmware and USB serial CH341A. In my case, they are COM9 and COM10. We can go back to OpenPNP. Let's give a brief look at the interface, but we will learn by working on it. On the left, we have the camera's window. You can select the top vision. This is the upper camera looking down, the bottom vision. This is the lower camera looking up, or both. You can even control the camera's LED with the icon on the top right corner. Under the camera window, there is the jog controller. It allows you to move the head of the PSE-3000, rotate and move vertically the nozzles. Pay attention. The movement or the actions that you will perform will be performed in relation to the target selected in this field. For example, if you click to lower or rotate a nozzle, will be moved the one selected in this field. The same if you want to unload a nozzle. The target nozzle must be selected in this field. You can start setting a speed of 25%. Okay. Most of the tabs on the right are strictly related, like in a database. These are Job, Parts, Packages, Vision, and Feeders. Machine setup and issue and solutions are for calibrations and settings. We will check those later. Job. This tab contains the uploaded board or boards, most of the time imported using Centroid files. Now I open a job previously created. The job contains a board. Clicking on it, you can see the components. Components are linked to specific parts in the parts panel. For example, all the 10K in this board are linked to the part 805-10K, which is linked to the package 0805. Each panel contains subpanels. We will see more later about this. One important setting in the GUI is the possibility to link the selected object in other tables. For example, if I click on a component, then in the tab parts, the related part will be selected. The same for the corresponding package, vision, and feeders. A little bit of glossary about terms now. With vision, we intend the system that allows OpenPNP to understand the rotation and position of components. The vision also allows to locate specific marks on the board, called fiducials. This system manipulates the images provided by the two cameras. in order to have a simplified version of the picture. This enables the software to understand geometry and positions. The number and type of manipulation steps can be changed by us, so to customize the vision system for specific components or fiducials. The PSE-3000 has already set visions. Those can be used for most of the cases. In another video, we will go a little deeper on vision. With feeders, we intend the small devices or plastic container which will provide the SMD components for the nozzles. They will be set in this tab. Issues and Solutions contains suggestions about setting and solution procedure for problems. However, it is not always true that a warning means that there is a problem. Some pieces of hardware require custom setting. So for now, don't worry. We will see this in another video. But now we need to let OpenPNP know by which ports it can communicate with the PSE-3000. And we need to activate the two cameras, top and bottom vision. We do this in the tab Machine Setup. So as I previously checked in the Device Manager, I have to set the COM ports. For me it was RepRap firmware, COM9, and USB serial CH341A, COM10. I set this under Drivers. Then for RepRap firmware, driver setting, I verify that motion control type is set to moderated constant acceleration, and I set the maximum feed rate to 50,000. It is the moment to start the two cameras. We begin with the top vision camera. It is in Machine Setup tab in the head of the machine. The head is the part that contains the two nozzles. Then we set the properties, set all the values as suggested on the right side. Default. Don't worry if the image looks dark. It is because we didn't turn on the LED. We cannot do it until we enable the machine, clicking on the green power button on the left. We wait for that. Now the bottom camera. Okay, in the camera windows I set the top camera and I try to click on the LED icon. This warning appears, the machine has not been started. So I cannot interact with the actuator that turns on the LED. We will do it, but before, follow me, we need to clarify something. Go to the Machine Setup tab and click on Reference Machine. Here we will find some important settings. The first one is Home After Enabled. It means that the machine will start the home procedure just after you click on the power green icon. Right now we keep this setting. Auto Select Tool allows the machine to decide when and which tool to use, according to the components on your PCB. Then we have the discard location. It is the position of the small garbage bin that I put close to the bottom camera. The garbage bin can be reached by the nozzles but not by the camera, because its position is far right. The soft limit would be activated. However, if the soft limit would have been set improperly, the machine would stop thanks to the limit switches. We need to mount the test board. The test board is a PCB containing fiducial markers and SMD pads. It is utilized to test and calibrate the PSE-3000. The calibration has already been done, so we just use it to check that all is okay and to verify some settings. Now, we start the machine. The PSE-3000 will start the communication with the software. Then it will position itself to the X and Y limit switches close to you. And it will jump to the set home fiducial pivot. The home fiducial will be recognized by the top vision system and the perfect homing will be achieved. All the coordinates of the machine will be reset to refer to this home fiducial pivot. The homing fiducial position and type can be found in the machine setup head. It is already all set. We will see how this works in another video. Here I just want to show you that if I position the camera close to the fiducial pivot and I click on visual test, the machine will center the camera on home fiducial, thanks to the visual system. Here you can also find the setting of the parking location. It is the point the head will move when you click on the P for axis X and Y in the jog control tab. It is good to have rulers on the camera windows for the top camera. So we will set this. Right-click on the top camera window. Some observations about the top camera. First of all, if you notice this white shape in the camera window, don't worry. It is part of the head. It gets inside the field of view. It doesn't affect the functionality of the vision system. If you just zoom in a little, you won't be able to see it anymore. We will cut a piece of metal for the next fairing supplies to fix this imperfection. Then, if you observe the camera view, it is a little bit rotated. This is done by the software during the calibration to compensate for small misalignment of the PCB holder and the camera during the assembling. If you go in the tab, Image Transform, you will see the field rotation. The value you will see is added automatically after the calibration. It depends on your specific machine. There is a setting that we need to check. It is in the tab, Top Vision, Lens Calibration. The lens has been calibrated, but, in my case, for some reason, the calibration is applied without the checkbox selected. It may be a bug, or the result of a mistake I made in the migration of the setting to the last release of OpenPNP. I need to investigate more about this. However, check about the distortion of the image. Drag the viewfinder to the center of the square, and then select the checkbox. If the image becomes distorted, deselect the checkbox. Another test you can perform is this. Zoom out and aim to a corner of a far pad. If the camera overshoots the point, it means that the calibration of the lens is not applied. In my case, if I select the checkbox, the camera moves further than the position I aimed. But if I deselect the checkbox, the camera moves exactly on the spot I selected. So I keep this checkbox deselect. Now we check that the steppers and the top camera are calibrated properly. We drag the camera viewfinder to a number in the centimeter ruler. You can zoom in with the mouse wheel. Then I set 10 millimeters in the jog window. I jog left, and if everything is okay, the camera should jump exactly 1 centimeter left. So far all is okay. Now we are going to verify that the position of the nozzle tips that I have configured are still valid. In OpenPNP terminology, the nozzles are the pieces of metals that support the nozzle tips. So in the PSE-3000 we have 2 nozzles. Those can load different nozzle tips. However, just to let you know, in case you need, you can install one more nozzles holder. A word about which kind of nozzle tips we use. Right now I'm providing Juki-like nozzles. They are good, but with time they tend to lose concentricity. This is fixed by the self-calibration every time a nozzle tip is loaded. But once they become old, they have too much tolerance and they move around the center. At that stage, they need to be replaced. This is normal. The original Juki nozzle may last longer, but they cost a fortune. I'm also experimenting with Samsung-like nozzle tips. Those may have better lasting eccentricity, but I don't like the system they fit on the nozzle support, which is completely different from the Juki one. In the future, I may change my opinion. Okay. Load manually the nozzles on the holder following this order. Then we go to the tab, Machine Setup, Nozzle Tips. I selected the tip 502 so I can read its settings. The system uses 4 locations. The first put the nozzle support in front of the nozzle tip. The second puts the nozzle support on top of the nozzle tips. The third gets the nozzle tip inside the support. The fourth extracts the nozzle tip. A look at these icons. You will use them to control the head or acquire positions for settings. The first moves the head, positioning the camera over the center of the location. The second moves the head, positioning the tool selected over the center of the location. Same for the third, but without retracting the Z to safe position. The fourth captures the location of the camera and writes it in the corresponding fields. The fifth captures the location of the selected tool and writes it in the corresponding fields. Okay, now I select the nozzle tip 505. I want to check that all is okay. I want to position the tool over the first location. I want to move the nozzle in one. This is the icon. Now I don't have to look at the camera window. There is an offset between camera and nozzles. This is already calibrated and taken into account. I need to go and check with my eyes that the nozzle in one is in front of the nozzle tip 505. It looks okay. So I go to the second location and move the tool, nozzle in one. I check. It seems okay, but I will not use the icon to lower down the nozzle. I want to be sure that the location is right. So I set the XY distance to 1 millimeter and I jog down step by step to see if the whole of the nozzle support can fit the nozzle 505 in the right way. It is okay. So I click on the P for the Z-axis, parking for Z, to retract the nozzle support. Then, I click on the tool icon for the fourth location. I want to try to automatically load the nozzle in one. Then I click on the P for the XY axis. These two icons are for unloading and loading the nozzle tips. Let's try. The PSE-3000 resets the Z position and goes to load the nozzle 505. Note that now we are just testing the settings. During a job, the PSE-3000 will decide by itself when to load or change a nozzle. Now we unload the nozzle. I want to do the same check for the nozzle in too, so I repeat the operations. First, I need to select the target nozzle in the jog window. In this case, it is nozzle in 2. First location. Second location. Down by 1 millimeter steps. Then park Z and park XY. Now I load the nozzle tip 505 on the nozzle in 2. Perfect. So if you didn't change any setting, all the other positions on the nozzle holders will be okay. I will try to load the nozzle tip 502 on the nozzle in 1. Note, this tip is far left on the nozzle holder and cannot be loaded by the nozzle in 2. It would reach the limit. All the other tips can be loaded by both nozzle supports. It loaded perfectly. I go to XY parking position. Then I unload both tips. Do not forget to set the target nozzle in the jog window. N1 to unload nozzle N1 and N2 to unload the nozzle N2. We verified that the nozzle tips tool change system is properly configured. It is the moment to see how to make and load a Centroid file in order to create a job. Then we will set up some feeders. Inside the folder PSE-3000 installation, there is this folder, PCB test and calibration. Within you can find a JSON file. It's a board made with EasyEDA. We go to easyeda.com to open this board and export a Centroid file. Later, we will create a Centroid file in Eagle. If you don't want to perform this step, inside our folder there is a Centroid file ready for OpenPNP. In EasyEDA, we click on File, Open, EasyEDA. We locate our folder. Click on the file, then click on Import. To export our Centroid file, click on File, Export Pick in Place File, then Export. The file CSV so created cannot be used in OpenPNP. You need to have a file comma separated. So we open this CSV file in a spreadsheet editor to convert it in the right format. I will perform this operation by Excel. In OpenPNP, I go to the tab, Job. In the board area, I click on the plus to add a board. Then I need to save it. Now we need to import the Centroid file made with Excel. So File, Import Board, named CSV. Locate the file and click on Import. Done. I can see all the components of my board. At this point, we need to tell to OpenPNP where this board is on our machine. To do this, there are several ways. I'll show you a simple one. Our PCB test has got 4 marks. Beside them, there are the coordinates of these marks. If you wouldn't have had them, you should have gone in EasyEDA to check their coordinates. In another board, you could use vias or even components paths. We will see this later in this video. Back to our PCB test. The coordinates of Mark 1 are exactly x0, y0. This is the board's origin. I drag the camera viewfinder on it. The green field on the bottom right corner shows the coordinate of the viewfinder, because in the jog window the camera is the target. Therefore, we have Mark 1 coordinate in relation to the machine. I want to acquire this location in the board fields. To do this, there is an icon which was created for this purpose. Set the board's location to the camera's current position. I click on it. If you cannot see the values just acquired, you need to resize the board area. Now I can read the board name and all the other values. Some values are still missing. The board Z value and its rotation. We start with the Z value. We need to load a nozzle tip to understand where the board is located on the Z-axis. We will lower the nozzle on it step by step until it touches the PCB. Then we will get the Z value. We load a nozzle. We know how to do it. I set N1 as the target nozzle. Okay. I still didn't save the job. I do it now. A look at these icons. I will position the camera's viewfinder to the board's origin, clicking on this icon. Now, I want to position the nozzle N1 on the board's origin. I set the target nozzle to N1. There is another icon that does just this. Now I'll lower the board by steps of 1 millimeter. So I set the jog distance to 1 millimeter, but when the nozzle tip will be very close to the board, I'll change the jog distance to 0.1 millimeters. When the nozzle will touch the board, I will lower the nozzle tip another 1/10 of a millimeter. In reality, you should do this operation for the lower point on the PCB. I can read in the bottom right corner, in the green field, the Z value. In my case, it is -13.9. I can write this value in the board Z field. Now we need to check for the rotation of the board. Well, the PSE-3000 will use fiducial points on the board, or marks, to calculate the rotation, and to define the board origin even more precisely. The visual system will be used. 2 marks are enough, but we will use 4. In order to use these 4 fiducial marks, we need to add them in the job component list. Let's do it. I'm going to add the 4 marks. Then I'll link them to the part, mark 1 millimeter 3 millimeter, which is linked to the package with the same name. I need to change the type to fiducial. Then I need to write the coordinates for the 4 marks. They are written on the PCB. And in the end, I need to check that the footprint size is 1 millimeter for this case. So I go to the Package tab and I change the footprint size. I go back to the Part tab. I click another part and then again on our mark 1 millimeter 3 millimeters. So I can verify the footprint is okay, but it is not. I go back to the package. I notice that I didn't press enter after I changed the value. Now it is okay. It fits perfectly on our fiducial. Now I can click on this icon to let the machine perform a check on the fiducial and update rotation and location in the board fields. Well done. At this point, OpenPNP should know where each component is located on the board. To check this, we let the camera's viewfinder to go over some components' location. I disable all the components. Obviously, I need my 4 marks to check the position of the board before starting any job. We will choose some pads to later place some 805 resistors. They are rotated at different angles. If the pad is rotated, also the viewfinder's ruler will rotate. To place components, we need to know their height. If you don't have a datasheet, you can use a caliper. As we can see from the tab job, components are linked to parts, and these should have feeders linked to them. If not, you will see these red lines. Missing feeders. We'll start to configure a feeder in the simplest way. Another video will be done to see advanced ways to manage feeders. It is possible to use the top vision system to pick up components on a strip, or even if they are scattered randomly on a piece of paper. We begin with a plastic rack, and we will not use vision. You could create a feeder by clicking on this icon, or you could go directly to the Feeder tab to see if a feeder is already linked. In the Feeders tab, I can see that there is already a feeder linked to the part R0805, but it is disabled. It is a reference strip feeder. It uses vision. For now, we want to keep things simple. We don't want to use vision. So we create a reference tray feeder clicking on the plus icon. The first thing to do is to enable this feeder. We load an available strip on a plastic rack. In my case, I had some 10K805 resistors, and we lay the rack on the working plane as perpendicular as possible. Please note, all the components and fiducials should be more or less at the same height. You should know that parts are linked to packages. There is a tab, Nozzle Tips. In it, you can decide which nozzle can pick up a component. Here we decide that resistor 805 can be picked up by these two nozzles, 504 and 504B. Now we need to acquire the pick location of the first resistor in the rack. I drag the viewfinder on my first resistor. If I'm bothered by the ruler rotation, I can reset the rotation of the target tool, in this case the camera, by clicking on this P. Okay. Now, to acquire this location, I need to click on this icon. Capture the location that the camera is centered on. Magically, the X and Y fields will be filled. Between resistors, there is an offset. In this case, it is 4 millimeters. I will verify it by jogging 4 times by steps of 1 millimeter. To be precise, it is -4 millimeters. In this case, the tray count will be 1 for the X and 8 for the Y, the number of components I make available. To test the positioning, I can click on the icon, command the selected feeder to perform a feed operation. Then on the icon, move the camera to the selected feeder current pick location. The first time you click on the icon, a nozzle calibration may be performed. Being a static feeder, the only result we will have is that the feed count will increment. Then clicking on the second icon, the camera will move over the increment location. Now, we need to assign a Z value for the components on the rack. In the pick location area, there is an icon. Position the tool over the center of the location. It moves the last nozzle selected or the nozzle in the target field to our first component. Now I lower the nozzle by 1 millimeter, and when I'll be close enough, I'll switch to 0.1 millimeters. Pay attention. This time I don't want to touch the component because this may cause the other resistors to jump. I want to stop 1 or 2 tenths of millimeter from the resistor. The vacuum from the nozzle will lift the SMD components up. Once I'm okay with the distance, I can click on the last icon, capture the location that the tool is centered on. The Z field will be filled with our value. Then click on Apply. As I can see, the second component is upside down, so I will pick this up to test an alignment and then I will discard it. Let's try to place some components on our PCB. But be aware that if there is not solder paste, the component also, if perfectly placed, may slip when the nozzle is lifted. This happens especially with packages having pins like the SOD23. The pins make a sort of spring effect. A solution for testing may be to put some double tape on the board. I'll use it later. We start with one resistor. I select our 2 and I press play. It seems like a very good placement. I can check with a camera. Please note that now our 2 is marked as placed. I click on the icon. Before I continue, I want to spin some words about footprints. I select my part, then I click on the tab Packages. In the tab Vision Compositing, there is an error. There is no footprint. Even if the vision will work without footprint, a proper footprint will help the bottom vision to work much better and will reduce the risk of misdetection. So I click on the tab Footprint and I create one. Then I click again on the tab Vision Compositing, and I see that OpenPNP has a solution for this package. It will be assigned automatically to the bottom vision using the small packages pipeline. If you scroll down, there is a package named 0805. This package already contains a footprint. It was imported automatically from an Eagle file, so there is an advantage working with Eagle. Let's go on. Now I need to reset the place component because I want to place them again. I've reloaded my plastic feeder, so I need to reset the feed count. Now I try with 2 resistors. The PSE-3000 is aware that the machine could use 2 nozzles tips to speed up the job, so it decides to load the nozzle 504B. Now it will proceed to a nozzle calibration to take account of the eccentricity. But it seems every time I try, there is a problem with the bottom vision on the nozzle N2. Very strange. It uses the same vision system of nozzle N1. After a while, I understood the problem. I moved the PSE-3000 close to the window, so I can use the PC with Windows 10. I set the system far from the window using a notebook with Windows 7. The problem is the strong sun illuminating the nozzle and causing the camera to recognize a much bigger area than the component. The solution is very simple. To close the curtain, let's try now. I want to place 6 resistors. If you are using the same pads, don't forget to remove the resistor from the pad. If you reload the feeder, don't forget to reset its counter. We click on play. Perfect. Let me check the component position now. Let's try with a transistor. Here for SOD23, I decide to operate only with one nozzle. As you can see, I've set only nozzle 504 for the package SOD23. Same procedure as before. I go a little fast. The vision system worked perfectly and the positioning was perfect, but the components jumped a little on the board. The pins gave back the kinetic energy. Here you can see it. A little bit of solder paste is needed or some double-sided tape. We will see this later. It is the moment to see how the automatic feeders work. They are easy to install and easy to configure. They can come in slightly different designs. These are micro switches. They control the tension of the film that needs to be peeled. The screw on top is the setting for the tension. The higher the screw is, the earlier the switch gets activated and stops the motor. So if you need more tension, you need to screw in. These two push buttons move the tape. The one on top moves forward. The lower one moves the tape backward. This switch turns the feeder on or off. On is on the right. Off is on the left. To install the feeder on the communication rail, unscrew this bolt. Then screw the bolt back. Turn on the feeder. It is the moment to turn on the rail. I click the Actuators tab. In it, look for Feeder Power Switch. But an error comes out. Usually it doesn't happen, but it is good to see how to fix small problems. I check the serial ports. They are both okay. I turn off the machine. I turn it on again. I enable OpenPNP. It goes through the homing fiducial procedure. And now I click on Feeder Power Switch. On the communication rail, the LED turned on. Now we set the feeder address. You can choose any number you want. Consider that this will be the address of the first slot. The second slot and the third will have an incremental number. Now I choose 13. The second slot's address will be 14 and the third 15. It is the moment to start configuring a feeder. I choose Reference Auto Feeder. I set the address. Then I test it. Okay, now I want to test the slots 2 and 3. I can do with an actuator. I set the address 14. Then 15. Pay attention. Every time you add a new feeder, you need to set its address. To do this, the other feeders must be temporarily turned off. After you have assigned the address to the new feeder, you can turn the others on. You can add as many feeders as you can fit. 12. Now I mount the reel holder and I place in it a reel of resistors. Let's go to feed a tape in the automatic feeder. Cut a tape like this. Split a hole in half. I insert the tape just under the push buttons. If these metal tongues are bent down, pull them up. You can bend them down a little after all is in place. Now I peel the film. I collect the resistors with a small magnetic tool. Don't let the resistors drop inside the feeder. Usually nothing happens, but we don't want the resistors to get inside a gear or on an internal PCB. I can use these resistors later with a special feeder setting. It is possible to use the top vision system to pick up components even if they are scattered randomly on a piece of paper. Push the tape down a little after it passed this metal tongue. If you don't do it, the tape will go from the back following a straight path. It needs to go out following a curved path, like this. The plastic film needs to follow this path. There is a hex bolt here. It can regulate the pressure on the film. This gear needs to have traction on the film. But if it is too tight, it risks cutting the film. Now I can go on setting my feeder pickup location. I position the viewfinder over the point where the pickup will be performed. Then I capture the location by clicking this icon. As before, to know the Z location, I need to lower on it the nozzle tip. So, target N1. And I click on the icon. Position the tool over the center of the location. When I think the Z value is right, I click on the icon, capture the location. Then click on Apply. Be sure to enable this feeder. Now, before I test the feeder, I need to perform a fiducial check of the board. I may have moved a little the board, picking up the components from it. Now I select only R225 and I click on play. Let's see how it goes. I move the camera to the placement location to check. Perfect. Let's try with more components. I move the camera to the next components to see if I want to select them. Okay. I want to use both nozzles 504, so I check in the package tab that both are enabled. I can click on play. Perfect placement, but it is better to have a little bit of solder paste or some double-sided tape on the PCB. Without, the component may slip under the nozzle after the placement. Now we will perform the steps of creating a Centroid file in Eagle. Then we will import it in OpenPNP and we will create a board. We will use vias as fiducials. We will let the PSE-3000 to automatically define a more precise position of the board and find out its rotation value. I will use one of my projects. First, I create a Centroid file. I need to run in UPL. Mount smd.upl. I also save the bottom, but in reality I have a single surface. Then I will use 3 vias as fiducial points. I take note of the origin of my board, that is just in the bottom center of the board, below the USB. Now I take note of the coordinates of the 3 vias. As I did before, I need to create a new job. I click on plus to create a new board. I save it, and then I import in it the Eagle Centroid file. In my case, I have only the upper surface, so I browse only for the MNT file. Here the feeders are already set because it is a board that I have already assembled many times. But in reality, the settings in the feeders tab are no longer valid because I'm on a new PSE-3000. Those feeders are not even installed on the machine. Same steps as before. I set more or less the 0 of the board. I know where it is, just below the USB. I acquire the camera location. Then I need to create 3 fiducial marks in the components list. I check in the footprint tab the diameter. 1 millimeter seems to be okay, but later we will see that this is not the case. Now I select a component on which I'll check the Z position of the board, lowering the nozzle on it. I write my value, minus 13.5. Finally, I can perform a fiducial check of the board. Watching the camera, it seems that the fiducial check didn't center on the fiducial mark 2 and 3. Let me check the component position now. I can see clearly that now OpenPNP thinks the pads are not where they should be. OpenPNP now has a wrong coordinate system for the board. This is caused by a bad fiducial check procedure. I think I know where the problem is. I need to increase the footprint diameter for my fiducial vias. 1.5 should be okay. Now I need to manually acquire the origin of the board again. Then I perform a fiducial check. I check again for the position of the pads, positioning the camera on them. Okay. Now I'll try to place some 10K resistors. I need to set a feeder. The feeder already configured for this part in the setting is not there. But I could use the feeder utilized for the PCB test. I need to modify something. First, I need to disable the current feeder assigned to the 10K resistors. Then I go to the feeder assigned to the part R805, and I change its link to the part 0805-10K. I try to place some components, but this board doesn't have smooth pads. The components were slipping. I didn't want to use solder paste, so I used double-sided tape. I try with these 4 pads. The positioning is again perfect. Removing the tape from the feeder. The first step is to cut the plastic film, because if you don't cut it, the micro switch stays enabled and the motors will not work. Then cut also the tape coming out from the back. Pull up the metal tongues a little. Push the backward button. It is the lower one. If you push for more than 3 seconds, the motor will keep rolling. Then pull with your hand the tape. When you have done, stop the motor, pushing the forward button once. Let's see a small problem that may happen. If you experience a frozen image, maybe the camera has lost connection. So disconnect and reconnect the USB cable on the PC side. Then go into the camera setting and click on Test. It should get back the connection. If it still doesn't connect, power off the PSE-3000 from the power switch on the back. Then turn on it again. More videos about OpenPNP and calibrations will be available soon.